Hey guys, I just wanted to go through a practice problem with you and show you how to do it in Mathematica. So I've chosen practice problem 3.1.2. It's a pretty simple problem, but we'll go through a couple different ways you can solve it, and one of the ways at least that we'll show you here with Mathematica might be useful for other problems. So first let's go through, I kind of tried to set this up the same way you guys do your homework with given, find, and solution. So we're given a few things. We're given f1, f2, and they're intersecting at this point A, and then we're given the component values for f1 and f2 in the x and y direction. So let's go ahead and put those in. To make a variable in Mathematica, we'll just name the variable first. So we'll say f1, and we'll do the x value first, and then set it equal to, and that value is -10. And then I'll put the semicolon to suppress the output. If I don't put the semicolon, this is what it looks like. If I hit Shift Enter now, then it outputs that. So if I don't want to see that every time, then I just put semicolon and then Shift Enter, and it evaluates. So I have f1x defined. Now let's define f1y, and that is also -10. So I've got those. Now what about f2? I've got f2 in the x. That's set equal to 70 is what it tells us. So colon Shift Enter, and then f2 in the y direction, they give us -90. Great. Okay. Now, what they say in here, they give a couple keywords. They say to maintain equilibrium at point A, where these forces intersect f1, f2, and f3. That's what they want to know, is how do we maintain equilibrium? Well, equilibrium means that nothing's moving, so we know that if we were to sum all the forces in each different direction, in the x direction or in the y direction, the forces summed would equal 0. So we have to figure out that situation. If I sum all the forces in the x, it's going to equal 0, and if I sum all the forces in the y, it's going to equal 0. And we know the forces, the components of each force in two directions, but not in the third. So we can set this up fairly easily. There are a couple different ways we can do this. The first way is if we use Mathematica's solve function, and I'll show you guys that first. That's what will very possibly come in handy later for you. So if I type capital S, that's important, capital S, solve, and then square bracket, I can put in my formula, which in this case, everything's going to be equal to 0 for the x direction, and then double equal sign is is the convention we have to use for saying solve. So 0 double equal sign, and then I'm going to just put in the different factors. f1 in the x plus f2 in the x plus f3 in the x. Now f3 I haven't defined yet, but if I hit comma, and then I say f3x, that's what I want you to solve for. It's going to say, okay, I can do that. And I close the bracket. So this is my formula part right here before the comma. 0 is set equal to f1x plus f2x plus f3x. And it knows what f1x and f2x are, but not this f3x. And that's what I want it to solve for. That's the second part. And then if I hit Shift Enter, it will solve it. And it says, look, it's -60. So there's another way that we can check this. We could just do the algebra ourselves, and in this problem it's pretty easy algebra. We can say, what is f3 equal to? If we isolate f3 on one side, then we end up with f3x, and we'll just say 2 for the second answer, or the second way to solve it, is equal to -f1x minus f2x, because we moved those over to the other side of the equal sign. And then I'm not going to suppress the output and hit Shift Enter, and we'll see what f3x2 is. It should be -60. Ta-da! It is. Great. So we know that that solve method worked for us. So you can do it either way. You can use the solve formula, which is handy when the algebra is not so simple, or you can just do the algebra yourself and get it to pop out the answer. So next we'll do the y values, and we'll just be lazy and do solve. So solve 0 is equal to f2 or f1 in the y direction plus f1 or f2 in the y direction plus f3 in the y direction. And we want to solve for f3 y. So then I'll hit Shift Enter, and true, and 100 is the value. So my values for x and y in the f3 direction are negative 60x and positive 100y. Now, does that make sense? Before we hit grade, let's enter it and hit grade. Let's do a little sanity check. If I look at f1 and f2, f1 in the x direction is negative 10, f2 in the x direction is positive 70. So given these unbalanced forces, so far it looks like there's a bias towards going in the x direction positively, about 60. And hey, look, to balance it, and with f3 we have a value of negative 60. That seems about right. And then something similar in the y direction, we've got negative 10 and negative 90, so a total of negative 100. To balance that, we need a positive 100. So I have a good feeling that we're going to get this right. So negative 60 in the x and positive 100. Let's hit grade, and we got it right. Nice job.